This problem, we want to determine whether each function is even, odd, or neither. So let's go look at our graph. I'm going to press my y equals, press clear, and then I got x squared, so I do my x key, my x squared, plus 3x, and then graph. And I see it's not even. If I started with this piece right here, if I flip it across the y-axis, reflect it across the y-axis, there's nothing for it to land on right here. So it's not symmetric to the y-axis, and it's not symmetric to the origin. Because if I started with this quadrant right here, the second quadrant, if I flip it across the y-axis and flip it across the x-axis, there's nothing for it to land on down here. So it's not symmetric to the origin. Which means this problem is neither. Now, graph-wise is how you want you to do the homework. But if you're curious how to do the by hand, we got f of x is equal to x squared plus 3x. It's best if you use y instead of f of x. Now, to tell if it's even, what you do is you plug negative x in for x and see if you can get it to equal the original function. So we got negative x to the second power plus 3 times negative x. Well, negative x times negative x is a positive x squared, and 3 times negative x gives us negative 3x. There's no way I'm going to be able to rewrite it such that it looks like the original function. Now for our odd, you put negative y in for y, and you put negative x in for x, and you see if you can get your original function. Well, negative x squared would give us a positive x squared. 3 times negative x is negative 3x. Now, original function has a positive y here, so I can multiply everything by negative 1. Negative 1 times negative y is y. Negative 1 times x squared is negative x squared. Negative 1 times negative 3x is a positive 3x. And here's our original function. And it's close, but I can't get it to look like the original one. And since the answer is no on both of those, then it's a neither. Again, all I want you to do on homework is graphically, but if you're curious how to do it algebraically, that's how you do it.